They can be as small as a bird or literally as large as a passenger jet. They can watch, they can supply, and they can strike. Yeah, we're talking about military drones. And today we're going to break down how this tech isn't just changing the battlefield, it's building a multi-billion-dollar industry that is completely reshaping the future of war. And the numbers? They are absolutely staggering. By 2030, the global military drone market is set to be worth over $22 billion. Just to put that in perspective for you, that's more than the entire GDP of Iceland. And this isn't some slow creeping growth either. We're talking a 7.6% annual growth rate. It's just being fueled by this constant global demand for unmanned eyes in the sky. Okay, but to really get a handle on this massive market, we kind of need to look past all the sci-fi headlines and ask a really basic question. What exactly are we talking about when we say military drone? At its heart, the definition is surprisingly simple. A drone is just an unmanned aerial vehicle, a UAV, or in plain English, an aircraft with nobody on board. But, that simple definition hides some incredible complexity, because the real difference, the interesting part, is in how they're actually controlled. So on one side, you've got your remotely piloted aircraft, or RPAs. The best way to think about this is like a super advanced video game, right? You have a trained pilot sitting in a ground station, maybe thousands of miles away, flying the aircraft. But on the other side, and this is really where the whole industry is going, are fully autonomous drones. These things use complex software and GPS to fly a pre-programmed mission all by themselves, no joystick required. All right, let's dive into the why of it all. How did this technology become so essential for modern militaries? What's really fueling this $20 billion boom? Well, it really boils down to four key things. First up, the rise of asymmetric warfare, fighting smaller, unconventional forces. That means you need constant eyes on the ground, a job that's just perfect for a tireless drone. Which leads right into the second driver, a huge demand for ISR. That's intelligence, surveillance, and reconnaissance. Then, of course, you've got rapid advancements in AI, which are making drones smarter every single year. And finally, with defense budgets on the rise pretty much everywhere, countries just have more money to pour into this kind of tech. And this chart, wow, it really puts that demand into perspective, doesn't it? We're looking at a market that's projected to jump from nearly $16 billion in 2025 to almost $23 billion by 2030. That's a $7 billion jump in just 5 years. It's a crystal clear signal that militaries around the world aren't just dabbling with drones anymore, they are absolutely doubling down on them. So we get why they're in demand. But how do these incredibly complex machines actually work? I mean, what's keeping them in the air and letting them do their jobs? A typical mission, it's like a carefully choreographed dance, really. It all kicks off with the launch. From that moment, it's in constant communication with ground control, usually bouncing signals off a satellite. Then it uses GPS to navigate to its target. Once it's there, it's showtime, payload use, deploying its cameras, sensors, whatever it's carrying. And finally, it executes its recovery sequence to come back home for a safe landing. Every single one of those steps has to go off without a hitch. And right at the heart of it all is the flight controller. You have to think of this as the drone's brain. It's this powerful little onboard computer that's constantly crunching data from all the sensors and taking in commands from the pilot or its own program, and then translating all of that into super precise instructions for the motors. And to keep the flight smooth, it relies on something called gyrostabilization. The best analogy for this is the drone's inner ear. It's constantly sensing the tiniest little shifts in pitch, roll, and yaw, and feeding that information back to the brain, the flight controller. The controller then makes thousands of tiny adjustments every second to keep the flight perfectly level, even in gusty winds. It's pretty amazing. Okay, so we know how they work. Now let's slice up the market itself. Who's buying them? What are they using them for? And who are the big companies building them? So if you break it down by what they're used for, the biggest piece of the pie, by far, goes to those ISR missions. These are the scouts, the watchers, the intel gatherers. They face a lot fewer political hurdles than armed drones or UCAVs, and their job is just fundamental to pretty much any military operation you can think of. This table here gives us a fantastic snapshot of what really dominates the market. So in terms of the platform, it's the big strategic drones, mostly because they can fly anywhere in the world. For application, like we just saw, it's all about ISR. And by type, fixed-wing designs are king, simply because they offer way better endurance and efficiency, which is exactly what you need for those long surveillance missions. And this whole market is pretty much led by a handful of heavy hitters. We're talking about companies like Northrop Grumman, RTX, and General Atomics. They are the absolute titans of this industry. So it's really no surprise that North America holds the biggest market share, driven by huge defense budgets and, well, having these key players right in their backyard.
But, it's not all smooth flying. The future of drone tech is filled with some pretty big hurdles to get over, but also some absolutely game-changing opportunities on the horizon.
One of the biggest challenges isn't the technology, it's the people. There's a major bottleneck right now in finding enough skilled pilots and data analysts. I mean, you can build the most advanced drone in the world, but if you don't have enough trained people to fly it and make sense of the data it's sending back, it's not nearly as effective. But on the flip side, a huge opportunity is in a field that's a little less glamorous: logistics. Just imagine replacing a risky truck convoy or a loud, vulnerable helicopter with a quiet, autonomous drone, using them to deliver critical supplies. Ammo, food, medicine, right to the front lines isn't just more efficient, it actually saves lives by taking human pilots out of harm's way. This is quickly becoming a massive growth area. And the innovation just doesn't stop. Engineers are now developing these incredible hybrid electric propulsion systems that solve two big problems at once. First, they're way more fuel efficient, which means longer missions. But here's the really clever part. They let a drone switch to a nearly silent, electric-only stealth mode when it's getting close to a target, which makes it incredibly hard to spot. And this isn't just some drawing on a whiteboard. It's a real strategic priority. As Dr. William Cohen from the U.S. Army points out here, these advanced engines are critical. They boost endurance, and crucially, they make militaries less dependent on those long, vulnerable supply lines for fuel. So all this incredible technological progress, smarter software, more autonomous systems, it all leads us to one final, really important question. As these flying machines are given more and more authority to make their own decisions out there on the battlefield, it really forces us to ask, who is truly in command?